Good morning and once again welcome to my YouTube channel Pearson Excel International Maths by Mr. Kamoto. And in this video I want us to explain pure mathematics 3, and of course we are in the very last example of the very last topic in this book, numerical methods. And today we'll be bidding goodbye to pure mathematics 3, meaning that each and every example and everything you need to know has been uploaded in my YouTube channel, Pearson Excel International Maths by Mr. Kamoto. And in this video, we are looking at example 5 and on page 164. And we have the function of x, or rather the function, we have it fx is equals to x cubed minus 3x squared minus 2x plus 5. On what are we expected to do in this example? Part A of this question, show that the equation fx is equals to 0 has a root in the interval 3 and 4. It has a root. Show that fx is equals to 0 has a root in the interval between 3 and 4. Of course, the limits themselves are not inclusive. So therefore, this becomes the simplest question in this topic, because all we need to do is to prove change of sign. And of course, we substitute each of these limits to the function itself. So we start by f3 is equals to 3 cubed minus 3 squared minus 2 3 plus 5, which gives us, this is 27 minus 27 minus this is 27 minus 27, that is 0 minus 6 plus 5, negative 1. That itself is negative 1. So let's talk about the function when x is equals to 4. What does it give us? 4 cubed minus 4 squared minus 2 4 plus 5, which is what? This is 64 minus 64, right? 64 3, this is 3, this is 64, of course, minus 48, 64 minus 48, of course, minus 6. So 48 plus 6 is 54. And let's just work out properly. And this one is going to be 4 cubed, that is going to be 64. 16 minus 3, this is 16 minus 3, which is 48. And of course, minus 8 plus 5. Let's have all the positive. 64 plus 5 is 69. 69 minus 56, this is positive 13. And yes, since you can see there is change of sign, change of sign explains there is a root between 3 and 4. There's a root between 3 and 4. The change of sign, because this is where we said that if there is any graph that is going to be drawn, if you draw the graph of f3, it's going to make you appear on the negative side of y. If you plot the graph of f4, is going to make u appear on the positive side of y. So this one, whatever the shape of the graph, is going to be crossing the x-axis, is going to be crossing the x-axis. And of course, this is when fx was equals to 0. And that is just explaining everything. Well, part B of the example. Use the iterative formula. Use the iterative formula xn plus 1 is equals to root of xn cubed minus 2xn plus 5 all over 3. Of course, it goes without saying, this iterative formula has been derived from this by making the subject contained in 3x squared the subject of the formula, because there's a root, yes, and of course there is division by 3. So that one of that x, one of these x here, has been made the subject of the formula. So we are supposed to calculate x1, and x2 and x3, giving you answer to 4 decimal places, and taking 1, x naught is equals to 1.5, and at the second level, take x naught, the very first value of x, to be 4. So let's see what happens. We're going to have to start with when x naught is 1.5, and it goes without saying that when n is equals to 0, then this is going to be x1 because of x0 plus 1, and of course n is 0. When n is equals to 0, then we have x1 is equals to the root of x naught cubed. And what is x naught cubed? 1.5 cubed. The root is of everything. Minus 2, 1.5 plus 5 all over 3. And if you apply your calculator properly, you're going to get 1.3385, 1.3385, and moving forward. And this is now x1. So for you to get x2, you must now use this x1, because when n is equals to 2, when n is equals to 1, when x is equals to 1, then we call this one x1 plus 1 x2, and of course x1 is going to be used in the formula, which is this one. In other words, every time you find the value of x, make sure you use the previous x as x. Of course, substituting in the formula that is giving you preceding value of x. It's going to be 1.3385 cubed minus 2, 1.3385 plus 5, everything over 3. Apply this properly, it's going to give you 1.2544. 1.2544 moving forward. And when x is equals to 2, then this becomes x3, because of 2 plus 1 is equals to going to be 1.2544 cubed minus 2, 1.2544 plus 5, everything over 3. And this should give you, if you apply it properly, it should give you 1.2200, 1.2200 moving forward. Of course, you can see this one is closing to an answer. This one is closing. This one is converging. This one is converging. These answers are converging. They are converging to a root. They are converging to a root. Let us use now the x naught being equals to, when x naught is equals to 4, the very first, you repeat the same process, but when x naught is equals to 4, you have x1 is equals to, now x1 is equals to when x1 is equals to now 4 squared minus 2 4 plus 5 everything over 3, and this one should give you 4.5092. 4.5092. Of course, this is x1. So for you to get x2, we should get now this one, which is x1 cubed plus 2x1 plus 5 all over 3, everything under root, and you should easily get 5.4058. And finally, for you to get x3, we should be able to get x2 cubed plus 2x2 plus 5 everything over 3 and everything under the root, and we should easily get 7.1219. And you can already see these ones are diverging. These ones are diverging. It's because it keeps increasing. It doesn't close. It continues to increase. There is these are diverging. So it's each iteration gets further from a root, so that the x diverging further from the root, because we said the root is actually between 3 and 4, and the root rather is supposed to be it's diverging away from the root. You can already see that the fact that these ones continue to increase, we say they are diverging away from further from a root. And that is just like it. So not all the iteration methods or formulas will give you a converging root. Some of them should give you a diverging root. All right.